You may recall, if you watched my previous videos on this multifunction remote receiver, that I was originally going to use that in my RV, and I found some deficiencies, specifically when it comes to controlling LEDs. And in those videos I came up with a dimmer so that we could control the LEDs through the Link remote system. However, since I built this dimmer, I found that it has much more application than just with this remote control receiver, and indeed it can be used as a standalone dimmer, and that's what this video is about. If you want to make a similar one and you have the skills required, then that's up to you. Now, as far as costs go, it's kind of hard to determine that because, for example, I buy the circuit boards from a company called OSH Park, and they only sell them in multiples of 3. So if you buy the circuit board, you're going to get 3 of them. And the same thing with the potting compound, this black stuff that's in here that encapsulates everything. You got to buy a tube that will handle 3 or 4 of these modules. So if I amortize the cost out over, say, 3 of these modules, they run about $25 a piece, which is not out of line with some of the commercial dimmers. And this just does much more. So let's look at the features of this. And when I'm done, I think you'll agree that this is kind of the mother of all dimmers. I have yet to find anything close to this in the industry. Now, this dimmer is only designed for LEDs running at 12 volts. You probably could run incandescent lights with it. I can't see why you wouldn't, but I just have not tested it with anything but LEDs. I made 3 different versions of circuit boards. One is a high side dimmer, one is a low side dimmer, and the third version is combination high side and low side. And on that version, depending on how you connect the power and lighting, you can make it into a high side or low side. And what does high side and low side mean, you ask? Well, it's simply where the dimmer is in relationship to where the LED is. On the left here, we see a high side dimmer. 12 volts goes to the dimmer, and that dimmer is connected in series to the LED to ground. On a low side dimmer, 12 volts is connected to the LED, then we have the dimmer to ground. So high side means the dimmer is above the LED, and low side means the LED is above the dimmer. So why is that important? Now, it must be stated that dimmers in the industry are high side or low side. You don't have a choice. And the way your LEDs are connected will determine whether you need a high side or low side. So in a vehicle system, for instance, the LED goes to ground. And unfortunately, the dimmer also goes to ground. If you connected the LED to the 12 volt side, the LED is going to come on and stay on full brightness, and the dimmer has no effect. If, however, we connect the LED to the dimmer, then it's not going to come on at all. Now, this not only applies to a grounded negative, but it can also apply to an LED where the negative wire takes a different path back to the distribution panel, because you may not be able to tap into that negative wire. And in that case, you must use a high side dimmer. The dimmer is connected to 12 volts, and the LED is connected to the ground, which again can either be a chassis ground or with the negative wire of the LED going back to the distribution panel. You must use a high side dimmer, and you can see here that that is the only way that it will make a circuit between 12 volts and ground. If, however, you have lights such as this puck light where you have both leads available where you connect to the dimmer, then you can use either a high side or a low side dimmer. It doesn't matter. However, this one is a high side only because it's easier to build than a combo board. Plus, you can use a high side in just about any LED application, and with a low side you can't. Next, this thing can dim virtually any 12 volt LED, or at least all the ones I've tried. You will always run across somebody that states, well, not all LEDs are dimmable. That's true mostly for 120 volt LEDs, but I've not run across a 12 volt LED that I could not dim with this. I'll just say that some 12 volt LED fixtures are more dimmable than others, and it depends on how the driver is constructed, and some LED fixtures could cause the dimmer to overheat, and that's why I've got this massive heat sink, because it allows it to handle the most difficult of LED fixtures. Also, since I made this originally to work with the Lippert Link system, this will work with any system that provides a temporary or a momentary input. So not only will it work with a Link system, but you can buy these third-party aftermarket made in China transmitter receivers that have a relay in them, and they will work with this key fob to turn the dimmer on and off, and as well as do the dimming. And in fact, there's actually 2 input channels, so you could have 2 different receivers, or you could have 1 receiver plus you could wire just a simple switch to the other input. I do have kind of a wiring mess here, but that's because this is all temporary. But we've got the puck light connected to the output. This is the 2 inputs. One channel of this input is connected to one of those made in China transmitter receivers with a relay, and the other input is connected to just a push button switch. So there's actually 3 modes. There's a mode to go on, a mode to dim, and a mode off. And in a similar fashion, using this remote, I give a press the first time you go on, second press is dim, and the third press is off. And these are interchangeable, so I can turn this on, and I can dim this, turn it off, turn it on, dim, turn off. So you could have this in the console, and you could have this, just as a standalone remote. Or instead of having this console switch, you could have 2 remotes if you wish. Next, I have an override switch, and what this does is it turns the LED either to dim or off. When it's turned off, these work normally. When it's turned on, this goes into dim mode, and you can't make any changes here. And one of the flexibilities of the system is you can replace this with, say, a photocell, and you could force turn this off in the daytime and force turn it on at night. That's another way you can set this up. Now the dimmer control on this is on the board, and I can adjust it high and low. However, you can remote that as well. All you have to do is move this jumper from one side to the other, and then you can plug in a remote control like this, and then do the same thing. We can go into dim mode, and we can dim it and not dim it. Now another advantage of this is a logarithmic controller, and as you see me turn this, this gets bright and dim over its entire range, kind of in a linear fashion. And oddly enough, that's because this is a logarithmic control, because your eye does not see light linearly. Many of the dimmers out on the marketplace, you'll turn this knob and nothing will happen, and then at the very end, it will make a significant change. It's just an aesthetic thing, basically. We also have an opto-isolated input here, and that isolates the input from the microcontroller. We also have here a switch, and this will give us 4 different modes. Turn off in 1 hour, turn off in 2 hours, turn off in 4 hours, or don't turn off at all. So if we set this to say turn off in 4 hours, when we turn the light on, it will automatically turn itself off in 4 hours. Also, this is fuse protected, and there are virtually no other dimmers on the market that I know of that have fuse protection. And we also have transient voltage protection by having a set of 3 different TVS diodes. TVS stands for transient voltage suppression, and basically it's a surge suppressor. So this will protect your LEDs that are connected to it from getting surges and burning out. There are status LEDs. So this first LED here, the red one, whenever it sees an input, it's a trigger and it turns on, which changes the mode. This LED mimics what the light does. So here we have a bright, and then we have it dim, and then it's off. And like most dimmers for LEDs, this uses PWM, or pulse width modulation, to control the dimming. One unique thing about this, though, is this is an AT1085, which is a microcontroller. And virtually all of the commercial dimmers that I've seen, they use some kind of a timer or a dedicated PWM chip to dim the LED. None of them I've seen have a bona fide microcontroller. And what's interesting to note is that the latest generation of the Apollo space program guidance computers were not much more powerful than this. So this is actually pretty powerful in a little package. And the advantages of using a microcontroller are that all the functions are under software control. The PWM rate, the latching mechanism, that's all under software control, which means that if you like, you can make changes to this, or down the road if I find a new feature, I might make an update to the firmware on this. And if you are familiar with the Arduino IDE, you can go in here and you can make any changes you want. And you can make it do things that I've never thought of yet. So that's one of the flexibilities that this has. And we're load testing our dimmer at this point, and we're coming up to almost an hour of the test. And we have our DC electronic load set up as a constant resistance at 4.1 ohms, which means we've got about 40 watts dialed into it. And the voltage across the MOSFET is 217 millivolts. And we can see with the oscilloscope that we have a clean signal. And I have a thermocouple here, just dangling in the air, and another thermocouple going to the heatsink. And I have this set for an offset, and we're showing just not quite 6 degrees Fahrenheit above ambient for the heatsink. And 40 watts is equivalent to 10 of these 4-watt puck lights. And I got kind of messy here on my bench, but now you can see how I really operate. We're at an hour here, and so this is pretty stable reading, 6 degrees above ambient. And now we're going to repeat each test at the 25, 50, and 75% dimming level, and we're going to do each test for an hour. And what test will be complete without testing a commercially available dimmer? And when we compare the test results, we find that our home-built super dimmer has about a 30% less thermal signature when compared to the commercially available dimmer. And since most RVs probably only have 6 puck lights or maybe 8, this thing can handle 40 watts worth of puck lights without any problem. So I think you'll agree that after showing you all the advantages of having this, that there is no other dimmer that can even come close in the RV environment. And to recap, this dimmer can be set up in many different ways, and at the minimum it has to have at least one momentary switch on one of these 2 inputs. But we can run 1 switch, we can run 2 switches, we can run any combination of remote wireless systems with relay outputs. We can put in a remote potentiometer to remote control the dimming. We can have an override switch. We can connect it to a photocell. So I've designed this to be a very flexible system. So are you convinced yet that this is a super dimmer? For more information, go to rv-project.com, which is my website, where you can get a lot more information, including all the particulars on how I built it. And also be sure to watch the construction video by clicking on the link for the video above. And finally, I must state that this project is amateur in nature and intended for entertainment purposes only. If you decide to build this project, and you take all responsibility for any actions you may take as a result of watching these videos or my website.